Assalamu alaikum. Hey guys, I'm back and welcome all of you to my new video tutorial. In this tutorial, I'm going to show you how to plot a regression line on your data. Probably in the meantime, you might have seen my previous video where I have demonstrated how to determine whether your data has a statistically significant trend or not using Mann-Kendall and Shen's slope analysis or test. However, in this video tutorial, I'm gonna take a little bit further step to advance to plot that trend line, regression line in your data using a very frequently used package called ggplot in RStudio. So without further delay, let's just jump into our tutorial. So to plot your regression line, first of all, you need to install that package called ggplot. To install that, just type install and pick the package and insert the keyword called ggplot2. Why ggplot2 not 1? The explanation to this question is that ggplot is called the grammar of graphics in our studio, our language. However, the latest version of ggplot package is the 2, ggplot2. That's why we picked that one. So if I run the package and it says that do you want to restart R prior to install? No. Just go with no for our case. Now the package called ggplot is imported in our interface. Now we can go ahead to work with that. So the second step, you have to check the library. Just pick the third one and here put the ggplot2 keyword and run it. Warning, package ggplot was built under R version 4. That doesn't matter, but it works well. So now the third step we have to follow to plot our data in plot interface is, let's declare a variable called ggp and use this symbol, and here we're gonna use ggplot function, and under this we're gonna insert our data. So for our case, the data is dummy, so I'm gonna just copy and paste the data. Okay, now after that we have to specify the aesthetic value, what we are intending to be attached with the plotting. So for that we need to use AES, that stands for aesthetic, and here we're gonna insert the variable called year and flood area. So I'm gonna copy and paste these two as well. So now we are finished of the main data to be inserted in our code and the variable as well. Now if we would like to add some more thing that would be convenient to demonstrate our data, whether our data is going to be displayed as point, line or polygon. So we will prefer only point. So for that we have to use geom point, and inside the geom point let's insert some more parameters. I'm just copying and pasting so that we can cut off the time. So first I use geoPoint function. Inside geoPoint I have specified some parameters. What are those parameters? Look, the first one is the color. What would be the point color? I used dark magenta and the shape 21 and size 2.5. And here also comes up the aesthetic value. Here fill color is cyan 4. If you have previous experience working in RStudio, you might have been experienced that RStudio has a color list where it also has the color keyword. So from that list I have picked up this cyan 4. It demonstrates a different sort of color. Now I would like to specify whether the legend would be visible in my plot or not. So I am just wanting to my legend to be to not be visible. So that's why show.legend is equal to false. So now once again, if I wanna add some more parameters to demonstrate my plot, then I can use scale fill manual color. So these are just the circle, one is the boundary color and the other one is the fill color. So let's specify the fill color manually. For that I have copied and pasted this code block, which is scale fill manual and values is equal to C is equal to dark cyan. So here I have used a vector called C, and here you could have used some more parameters, but I just use one parameters, which is value is equal to dark cyan. So in this stage, reaching this stage, if we run the code, let's see what happened. Look, this is the variable. Still our code is unrun. So if we wanna run the code, we need to call upon this variable which we assign in earlier block. So let's call upon this variable called ggp and run the code. Sorry, just ggp. Okay, look, here we go. We have this plot which demonstrate the flood area and the corresponding year. So the properties we assign for each plot are also aligned with our consent. Okay, now let's proceed to the next step to draw the linear regression line which will fit over this point data. So to do so, let's call upon first ggp and plus we're gonna use another function called geom_smooth. So let's geom_smooth, and under or inside this function we will specify the method by which the regression line will be drawn and the color of a regression line. So what would be the method? Let's first equal to method is equal to linear model, so which is in default in our lm as lm, and then we will specify the color. So the keyword call is equal to color in our studio, sorry, let's put the color called dark magenta, which is like the same this one. So I'm copying and pasting to avoid the misspell. And if I run the code, the very simple regression line should be drawn over our point data. So let's run the code. Look, the regression line based on our point data has been drawn, and the color is picked up as the magenta we specified. And as it's a linear model, so it's a straight line demonstrating how data went down from 2002 to 2021, 2021. So now we have to add some more elements to make it look appealing and more understandable. We have to work on the x-axis tick and y-axis tick, as well as the tick label, to make it more appealing. So if I would like to add some more elements to make it understandable, let's just start working with the x label and y label value. So I have to keep the previous code as well, this one, because I did not assign any variable using all this previous code. Only I just assigned a variable called ggplot. To combine all this code, I have to add them together. So let's just copy and paste the previous code to keep it same, and with that we're gonna add some more element. Eventually it will output a very good regression line over our data. So first let's add some more data. To add more code, you have to use the plus sign. So first let's put some code on the x label and y label. So to put x label code, let's copy and paste here x lab. It means you're gonna work with x label, and y lab, it's gonna working on y label. So here look, x label, it looks fine, it's labeled as year. However, look at this y label, which is flood area. It misses the space, so I just rectified that one. Now let's add some more element like x y continuous and scale x continuous. Like look at this starting value from x label and in value from x label as well. Same goes to y label, in value and start value. So it misses something. So I'm gonna just specify what would be the first value, first year to be demonstrated, and first flood area to be demonstrated in y axis. So to do so, we have to use scale y continuous, where we're gonna set up the limit like this one code here, x scale y continuous. Here I just specify the limits where it should start and where it should end up. So the starting point should be 500 flooded area, and it will go until to 25,000. And same, I will specify the limits in x-axis using scale x continuous. So let me just copy and paste that one as well here. Here I will use the break value which will be handy to read out our code. Let's use the comma. So let me just briefly explain what does it mean. Scale x continuous, it sets the limits 2002 to 2021. However, what would be the interval that sets that is set up by this portion of code which uses breaks and the sequence, the interval. So the sequence it will be broken down by 3 interval, 3 years. So that's why bi is equal to 3. So if I run the code, still you can change some, you can see some changes. Let's run the code and see. Look, there have been changes we could see after this block of code, like the flood area, the misspell spacing has been rectified, and the first year that should begin from x-axis, which is 2002, and it goes until 2020. So there are many things we change in this line of code. However, we have to add some more annotation, some more text in this inside this scattered plot to make it more readable and understandable. So like what is the p-value and what's the r-square value. So r-square value is something which is coefficient of determinant in linear regression model. That's very, very important to understand a scatter plot if it is included in the inside this graph. So first of all, we have to determine, we have to find out the r-square value using our data. So let's first calculate the r-square value. For that, let's declare a variable called linear model, and under linear model variable we're gonna set the LM linear model, and then here we have the flood area. Let's just copy and paste from here. Flood area, the first variable, and then we will use the change sign, and then we will put the second variable called year. So the linear model which will be drawn based on this flood area and year variable, and let's just specify our data, which is this one. Like you can also like type dummy, sorry, look, your data has been popped out automatically. Now let's call upon the summary function to see the R square value and associated statistics. And inside this summary function, just put the variable we set of call lmode. So if I run the code, there should be all the statistics are relevant to this data. So here, among the all statistics given in this summary, we're gonna pick a p-value, which is this one, 0.0197, and the other one is r squared value, 0.2103 or 21% approximately. So if we attach to this two value inside our scatter plot as a text, then anyone can have a look at it and can easily understand the regression line, how it is relevant to this value. So we have to just put this value inside our scatter plot. So to do so, first of all, we need to use a function called annotate, which works to add any text or any decoration inside your scatter plot. So here r square as it's an equation, so for that we have to use best function to declare a variable first, and then we're gonna call that variable inside another function called label. So bit by bit, let's add these two value inside the scatter plot as a text. So first, let's declare a variable called lb1, and you can use either equal sign or this sign. I'm gonna use this sign, both are equal. So here I'm gonna use best function, and inside the best function I'm gonna specify the r square value. So r square is equal to let's just use double equal. R square is equal to this value. Bear in mind, you must use inverted comma. Now you declared a variable called lb1, which contains the r square value. Now we have to keep the other code as well. So let's just copy and paste the previous code and paste here, and let's just add some additional code to this existing code. So first of all, I'm gonna use annotate function to add the p-value. So let's copy and paste annotate here, and here I'm gonna put the p-value, and p-value is 0.04, something like that. So you have to put the p-value within the inverted comma as well. Okay, so just close the bracket. Now I'm gonna use another annotate function to add the text like r square value inside my scatter plot. So for that, let's just copy and paste here. Annotate text x is equal to, here x and y value both in annotate function, denotes the position where the text should be put. Like x is equal to 2007 means x should be the text should be placed along this horizontal vertical line, and y is equal to 2450. It means that 25 is here and 2450 something like that. So here by x value it's specifying the vertical position, and by y value it's specified the horizontal position of the text where it should be placed inside the scatter plot. So here in both cases I used x and y value to position my text, and here I used pers is equal to 2. When you use any equation, put any equation, you can use pers is equal to 2, and label is equal to lb1. Why lb1? Because this is the variable I created to contain the r square value, then I call upon label is equal to lb1. So it sounds so far good. Now if I run the code, let's see what kind of change we can get. Look here, geom is equal to smooth using formula y versus x has been drawn. So this is my final output of the scatter plot that contains a regression line based on my data. I have used these codes, and if your data is different, so your scatter plot and regression line might look different from this one. So once you are done with this scatter plot, you can save your output just going to export section, and from here just click save as image, and from here you will specify the directory where you want to put your output, and here you can also work with the image format. I prefer to keep it with TIFF image. You can also PNG, JPG and other available option, and you can also work on the image size, just customizing the width and height, changing their value. And yeah, that's all for the time being. I hope you guys have liked my video. If you have, please do subscribe to my channel. I need your support, and definitely I will come up with another new video. Till then, bye bye, Allah Hafiz.